Ladies and gentlemen, it's hard to believe, but we've reached the point on the agenda when this is the last presentation of the evening, I could probably say. So in front of us, a business leader, a leader of the Mauritian Software Testing Board, an entrepreneur, a teacher. Lovelesh has many names, so the stage is yours. Please impress us with your experiences of what the challenges are ahead, automation testers.
Thank you. Thank you. Thank you, everyone. Thank you for being here. Thank you for joining this conference of mine. And you guessed it, it was wrong on the planning day. I'm not Warner, I'm Lovelesh. I'll be speaking about the expectation and challenges about awaiting test automation engineers today. And just to get started, to learn a bit about my background and who am I. So a little about me. I am Lovelesh Beeharry. I'm from Mauritius. I am currently leading a company, Global Exam Support Limited, and I'm a test professional by the industry, in the IT industry. So I'm specialized in manual testing. Right. So okay. So I'm specialized in manual testing and automation testing, performance testing, and now I'm starting on as well on security testing with AI and so on. And I'm a founder of MSTQB, which is the Mauritius chapter for ISTQB. And I'm a coach. I'm an ISTQB trainer. And yeah, that's a bit about me. So let's see what's on the table today. I'll be talking a bit about the evolution of automation tests in the industry for the last 20 years. We've been talking about automation tests, but the frameworks, the way the design and the implementation of those automation tests have been changing over those years. So we'll give it quite a quick insight of those evolution. Then connected to it would be the expectation from the industry. So given that there was evolution as well in the framework, in the design and so on, the expectation from the market was changing as well. So now, more than ever, the market, the industry is asking for a lot from automation tests, and we'll see into that. Then the challenges for the test automation engineers, things that I went through, things that my team as well went through, and how we overcame those challenges. Those will be discussed in the best practices and lessons learned, and we'll end the session with some questions and answers. Let's dive in. So, evolution of automation test. The first one is we need to kick back like 20 years back, where the automation testing was restricted. It was tool and competency intensive. So the tool was a heavy investment. It was only the big brand names that was able to actually invest in automation test or develop a tool for automation testing. Things, brand name like HP, Mercury, they were the first actually to provide those commercial tool for automation. And it was a heavy investment for the industry to pick up, right? And the return on investment was questionable. So some companies actually tried with those tools just to have this innovation brand that they are doing automation testing, but the return investment was a bit challenging for them to justify in the long term. That was the venture. Then we had the open market between 20 and 15 years back. So there was open source tools that came for automation. That started with one of the best tools right now is Selenium, which is quite versatile in the market. That in that period of time, Selenium did start, and they open sourced that automation. It was quick as well, pick up by the market. It was opening the market, reducing the return on investment as well. That was there initially, the high investment cost. So the cost of implementation was then lower, and but still, the competence level for automation testing with those tools as well were quite intensive. We needed to have some custom programming expertise to have those tools upfront running. Then we had 10 years back where there was the growth. So there was a wide programming language. The languages that was used by developers was now compatible or made compatible with the tools that we have for automation. There was the development of the concept of automation framework, where we started with page pattern automation design, where everything was in the code. The test data, the test cases, the framework itself was just in one script, and then we execute that. Then we had as well the data-driven testing framework, where the test data was externalized from the framework, where test data maintenance could be done by someone else. Then we had as well a new design, keyword-driven framework, and now we are talking about extended keyword-driven framework, where we have the test data, the test script, the test parameters, all external to the test framework, and those are actually being handled by different teams. So the test data maintenance team, the manual test team are able to now write test cases and so on. So those evolution, we saw it in the labs between 15 and 10 years back, where I characterized as growth of the market for automation testing. Then we had 5 years back. So automation is now immersed in all the companies that is doing testing. The word automation must be present over there. And we had the concept of codeless automation. Well, still questionable about the efficiency of those codeless automation tests, but it's there. You can write tests that could be repeated again and again through blocks. Tools like Catalan, tools like GUI-driven automation were there to sustain those codeless framework where you could draw a flowchart and just execute the test without any coding, without any line of code. And the market was flooded with tools. So we have Cypress, Catalan, new version of Selenium, and so on. All these tools get into the market, and it was more mature in terms of automation testing then. And now AI and self-healing tests are driving the market of automation. So these are new buzzwords in the industry for automation testing. We are able now to have tests that can heal themselves. There is one framework that I use quite intensively with Selenium. It's called Helenium. So when there is a locator or an XPath which is not found on the page, the Helenium framework gives me another alternative XPath or locator, and that's plugged into the test. So the test data maintenance just reduces. So that's self-healing test. Then we have predictive and flexible tests. So the framework as well now, what we are talking about, those tests, they should be able to adapt to the reaction, of the SUT, of the system under test. So if there is a pop-up appearing, we don't fail the test. We need a certain fallback strategy that will actually recover from that pop-up to continue the test. And with these designs, with these new features in automation testing, there is a very high return on investment on those frameworks. So we invested a little time to automate, but on the long term, we're saving hours of work for manual testing. So this would be the evolution for the last 20 years for automation test. Now, to understand a little more about the current expectation of the market, of the industry as well. So the first thing, in my last few companies I was working, these are actually some of the requests that we got. The first one was actually to implement a certain spice of randomness in the test. They didn't want like those tests to have test data that was static. We used to test application that was in French language, so we needed like French characters in the name, but those test data as well need to change from time to time, or each time we run, it should be something new. The way that we implemented this spice of randomness in framework was there is already web services out there that is providing these services, like to have test data generated on demand in different locale. There is test data parameter web service that I use from API layer as well that gives me these test data. And each time I make a call, I get different test data. And these test data, given that it's random, I'm getting test being the same step and procedures, but with different test data. And these as well unveil quite some different kinds of bugs that we weren't expecting. So the spice of randomness. Another way of doing it is, the first one was API. The second was we implemented was database call. So we have database adapters in automation framework, which is quite as well open to many test automation framework. Can connect to the database, run queries, and they can order by random. So each time you get a certain random data from the database and you pick up that random data, you implement it into the code, into the test, and then it's executed. And the last one is actually generating random variables. So on the go, you could generate random variables, and that's very important as well when you're running the test over and over again, where you need like unique identifiers and so on to be exactly unique, like timestamp and so on. So those would be adding as well to the spice of randomness. And each time the test is executed, let's take a scenario where you are searching for a certain item on an e-commerce website. Initially, the test would be selecting the first one and then proceeding with the flow, the first item that would appear, because it was easier to have a locator that would actually just be the first. Each time, the search result would at least give one item. So the spice of randomness, again, in this scenario would be to count how many items we have and select one at random and then move with the flow. And each time that you move with the flow, there is a certain different test parameters that are needed. Let's say there is an item that you can bid on. There is an item that you can buy. So that would be the second aspect of the expectation from the industry, is the soft failure of test. So we expect a failure from a certain flow to be just limited. One test case failed, that's fine. We need to just avoid the ripple effect of that failure onto the other test that is coming after it. One way of doing it is just to ensure that each test starts with a certain refresh, or page refresh, if that's possible. So we flush all the errors that is there in the past test. We flush all these errors and then move forward to the next test with a fresh environment. That would be the soft failure of test. Then we have the next one, recovery strategy for the test. That's a bit tricky as well, because that's the self-healing part, and also having conditional action. So let's say there is a pop-up that is appearing, and that pop-up is supposed to be there because of the item that you selected from the random part of the test. So there is an item that was selected at random, and there is a pop-up which appear and doesn't appear based on the item that you select. So from there, you could have conditional action. If the pop-up is appearing, you click on a certain button just to clear it, and then move forward with the test. Or you could as well use Selenium there, just to, or self-healing, any self-healing framework, just to move forward that test to ensure that the locators are then generated based on machine learning. Well, for self-healing tests, that's important as well to understand. For self-healing tests to be effective, we need to run the test over and over again. The machine learning architecture behind, they need to understand what you're trying to click, and they will give you probability of alternative locators. Based on that probability, you can select the top 5. You try with the first one, it doesn't work. Second one, you try it, third, and so on. You could filter that. They have these parameters that could be set. And from there, you could recover from a certain failure. So that would be the recovery strategy of test. Then looping of test. That was another demand where we had to support the operational work as well for the support team. So we use automation as well, not only for testing, but as support. We imported, for one of the companies that I used to work, we imported items from a legacy product to a new product. And for those items to be indexed in the database, we needed to go to one by one and click on save. That was done manually. So there was 5,000 items that was imported in one instance, and the plan was to have 4 people do it over the 3 days, 4 days, and then have everything indexed. So automation tests as well, automation framework, automation script could help on those things. You just need to loop over the test and change the parameter. And again, the database adapter and so on just plug into like Legos in the framework to make sure that the right data is being fed to the test case, it's executed, it's looping again on itself, the next data is being fed, and so on. And we were able to actually save 4 days of test by running it on 5-6 machines in 1 hour, and we were complete with 500 indexation for the new items imported. So that was the looping of the test. That was a demand that we got on the go while we were developing the framework, and also the high configuration of the test. So the industry expects now that we should be, once we have a test script or test automation ready, we should be able to run it on different test environments, be it on the UAT environment, on the test environment, on the dev environment. We use those automation tests to validate those deployment on the environment as well. So if we have a certain test that is working, that is scripted only for the test environment, but when you're swapping into the UAT, you have a high maintenance to do there, it's kind of defied the return on investment part of automation. So the idea is to write test cases that are robust and highly configurable so that we could swap environment, we could swap test data easily, and even swap connection to the database and API if ever needed. So those things, this is what I meant by an extended keyword driven. So even those test parameters are externalized outside the test framework. And this is important because then anyone not having even the automation knowledge or the automation know-how or how to write those tests or how to execute the test, they can just have this external file, configure it. It can be an Excel file, XML, or text file, or CSV file. They just need to update those files and just plug it into the framework and run the executable, and the test will be there. So that's the high configuration level of the test that is expected now from the industry. And also the demand was to have a high coverage and in the shortest time period. So that's always tricky for test automation engineer to define the coverage, because we also need to struggle with the maintenance. When we have like a 2% coverage every month, so there is a high maintenance coming after just a deployment because things change. And the XPath and the locators behind and the object identifier all change, and we need to maintain those. So the way of doing it, again, with an extended keyword driven, we could segment the responsibilities. For test maintenance, that was another team doing it because it was just test data maintenance. Could be the manual test team. We just train them on how to extract locators, how to use the actions that we have on automation and just write it in an Excel file. And for the test data maintenance, we can, again, use the API, or we have someone dedicated that would pick those test data and plug it into a separate file, and those two blend together with the framework to run the test. So initially, the writing of the test, the scripting of the test cases, the scripting, the coding of the framework, as well as the test data maintenance were all centralized on the test automation engineer, which is now the old way of seeing things, because we need to open automation as well to everyone so that they can contribute and they can take and own some part of the test. We had a quick coverage target for one of the company, where we were able to sustain like 70% of it in the first 6 months because we had the support of manual testing. So there was 20 manual testing and only 3 automation engineers. We have to cover everything. In the first year, it will be only half of the target that we met. Then we found the strategy just to have an extended keyword driven framework to involve the manual testing as well, just to reach those high coverage. Then we have extended verification. Well, having an automation framework is good. The tests are being executed, but finding those verification glitches as well is the target, is the objective. So with the adapters, we were able to play around a bit with the different verification that we can do. Verification on the URL level, verification on the UI level, verification even in the database level. So when there is a change that is happening, most of the time manual testers might miss it because the URL are not checked from time to time. So there was a feature that was developed where the URL will need to contain a certain path and a UUID format data. Those were missed for the first 2 weeks because the test, the automation test wasn't there. Those verifications were not ready, and they were actually being tested manually. That bug was not raised. But once we have these verification in the framework, that was the first failure that we got. And these extended verification is bringing value for things that could be easily missed by manual testers, because URL is something that is most of the time not checked. It's only the UI, the portal that is tested. And those extended verification does add value to find those bugs. And the purpose of having automation as well is to have an unattended test execution. It defeats the purpose if we have to get someone just to monitor the test automation. Otherwise, that person could have executed the test. So the idea behind is to run the test, go home. Tomorrow we have the report, and then through the reports, we are able to find false positive or bugs. So unattended execution is very important. And the ingredient, again, is the self-healing part, where tests could recover or have their strategy behind when there is something unattended unexpected happening. Then the test could still recover from it and avoid the ripple effect of that failure onto other test suite or other test cases. That's a real value when we can schedule the test overnight and then run it. and have reliable results. And to get reliable results, all these are connected again. So results can be sent by email, or we can have interfaces like Twilio and have those results on WhatsApp and so on, but the result need to be reliable. What I mean by that is the chances of it being a false positive should be low. So once we get a result, we get an HTML with this failure and so on, the tester must have this a high-level confidence that when we're trying it, they are able to replicate it. And it's not happening only with just automation, and manually you're not able to do it. That was one of the needs as well that we had to cater. And easy access to real-time result. So that was a tricky one, because down the line we had to reduce as well the execution time, and we were using multiple machines to do it. And to have access to these information, we needed like different tools actually combined together with our automation framework. We use Grafana for dashboarding. So dashboarding was mostly about the different graphs that we could have in terms of execution, in terms of how many bugs we have in real time while the tests are still being executed. And we needed to implement this database behind the time series database, Prometheus. That's one of the database that we've evaluated and tested and connected it with Grafana, where we had this dashboarding. So the tests were run on different machines concurrently, and we had one URL. Those machines were not even in the company. They were outside the company in different headquarters. And those machines were reporting to the network, and Grafana was just rendering it and giving us like the charts there. So that was, again, a need that we had to cater, and the value add to this was, well, before we got the result, we knew how to, what kind of bugs we are expecting, were there timeout, were there like 404 error 500 and so on. Those would be the value add, and the developers would have a peek as well in the code what's executing. Quicker execution, the way that we handle it is machine clustering. We use Selenium again. There is a Selenium grid where you can have the host and multiple machines connected to it. This host will split the test in a way that it's executed concurrently and independently. We had regression tests that we've scripted for one of the product that span over 17 hours. We used to run it during the weekend, and Monday we used to just check the result there, and it was a huge result. And the need was actually to run those tests as frequently as possible. So on one machine, 17 hours, then on different machine, on 4 or 5 machine, we can get the result in 4 to 5 hours, we get the compiled result. And the same test, if you have to do it manually, again, it was taking like days, a lot of manual effort to do those. And for that product, we were like 75% saving the manual test time. So that was the quicker way of actually implementing execution. And then we have the return on investment, so a reliable metrics for return on investment. That was a bit tricky, and there is a bias when you're an automation engineer. You want to show that the return on investment is very high for your tool, for the test that you're doing, and so on. So given when we've implemented the database behind and Grafana, we had reliable test execution time, we had reliable results as well, and we used estimates that was provided by the manual test team to run the same test. We benchmarked it. This is how I can say that on average, over the 8 products that we automated in the company, there was around 75% of time saving with automation. So that matrix we need to keep monitoring, because with features and so on, these metrics change. There is testers as well that embellish or optimize their test, and we need to make sure as well that there is a sustained return on investment, which is still luring for automation. And those were the needs that was there from a few of the companies that have been working on automation, and it's a compiled one where now the industry is moving towards automation with these ingredients in mind. Now, the challenges for us, for test automation engineers. So the first one is the tool bias. I was in that mode as well. We tend to stick to one tool. I started with Telerik Automation Framework, and yeah, that was the tool for me that should be there for automation in every way that I work, actually. In every company I work, that should be the tool for automation. But then I understood that each tool has their weakness, has their strength and their uses. For some company where the website appearance or the branding is important, maybe Applitool would be the best tool to use for visual automation. But then for functionality, maybe Cypress, maybe Selenium. So the tool bias is something that it's easy for automation engineer to fall in, but once we get to understand the need, the strength, and the uses for each tool, we should be able to negate that bias. Then the coding bias. Programming languages doesn't define the underlying automation design. So the design is more important than the language. There are some languages that are suited actually for machine learning. Python could be used for machine learning if there is a need for that. But when I was working in different companies, I developed the framework in C#, and then I thought it would be difficult as well for me to develop the same thing in Java, but it's just the syntax. The design stays more important in this whole picture. The design for the automation framework is what is more important. And this design needs to be on a Lego base where you can plug in and plug out things easily so that you don't need to write those things again, over and again. So the third one is the continuous learning. So the IT industry is changing for sure every day. There is new tools every day. There is new services, web services every day. And the continuous learning is important because otherwise, again, we'll use outdated technology, we'll use outdated libraries, and there are quicker and smarter way of doing things that is being invented and dispersed in the market every day. So these continuous learning actually give us some insight as well. And in the databases, like when we have to implement the keyword-driven framework, the extended one, the time series database, the Elasticsearch technology, and the dashboarding, Grafana, and so on. So we got those ingredients by talking to developers, by learning, by reading these materials. So continuous learning is definitely something that we really expect from test automation engineers, coming with the ideas of new design. Then the operational ease. It was always a focus for the NFT team, the non-functional testing team I was leading, to take all the complexity of the functionality into the code, rather than giving it into execution, scripting, or maintenance. So there was a lot of challenges in this to maintain this operational ease. For the one executing the test or maintaining or writing the script, it should be as easy as possible, but the code is, we can accept that the code is complex, and it's on our responsibility to actually make it easy. So the operational ease is something that is challenging, but it opens up automation to a wider audience then. And the last one is the foresightedness, which is required because automation framework design need to be future-proof. You won't rewrite the automation framework again and again once there is a change in the libraries you are using, when there is a change in the version that you're using, or any dependency that you're using. So the foresightedness is important, having a roadmap as well to understand the product, where we are moving, what new features will be there, and how these new features test would be implemented in automation. Right, and some best practices and lessons learned. So again, this is again from a few of my teams that I was in for automation. So we had to implement the whiteboarding session. I come up with an idea. My idea may not be the best. So the whiteboarding session is important to discuss with the team. We had seen ideas being scrapped. We have seen ideas being embellished. We have seen ideas as well just going out of the box and just not being implemented, or just believing in it and not implementing it anymore because there was a change in the need as well down the line. So the whiteboarding session is important to refine ideas, to discard ideas as well. So in estimation as well, in our side, we need to take some space, some buffer to innovate, to try new things, because we'll fail as well. And the idea of failing is to fail fast, learn and recover faster. So we implemented the wrong database, we tried it, it didn't work. We tried with a new database and then it worked. We talked to the developers and so on to have their insight as well on the database. And this is the way that we are learning from those mistakes, because we try things based on the domain that we are. It's not really something that would work for all the industry, for all the domains in the industry, but this is specific to a certain industry. Where we fail, we learn, we recover faster. The MVP and the POC, so the minimal viable product and the proof of concept, does its magic. So we implemented things on a proof of concept before deploying it to the whole team, try it on an MVP level, and then build on top of that like a Lego. Work closely with the manual testers and open automation script to them. They are of great help to us to increase the coverage. So that's where we've met as well with this requirement for the test coverage by working closely with the manual testers. Monitor the return on investment of automation project without bias, and that should be done regularly. We did it on our side every 3 months. Every quarter was just an evaluation of the return on investment, and challenge ideas constructively, again, to refine ideas with the whiteboarding session, and maintain high quality gates for committing test scripts and test automation framework. So what I mean by quality gates was when someone in my team or someone in the manual test team is writing an automation script, they need to run it like 3 times on one environment, 3 times on another environment, just to make sure that the locators are strong enough. There is little chances of maintenance. There is also ensuring that the locators are not specific to a certain product as well. So those quality gates were there before I commit the test case into the repository. The code as well were tested. We had a regression test just to test the framework, because it was using all the actions that we have. We had written one test just to test all the actions we had on automation framework, and that test would be the regression for the framework itself. So we were using the automation to test itself in a certain way. So these were the quality gates that we implemented to just ensure that we don't commit tests that would fail down the line, and we'll need to maintain it. We have a cycle. We'll get into that spiral where we write test, we need to maintain it, we need to write the test, we need to maintain it, and so on. And the maintenance cycle goes on. So the high quality gates did help us to just break that spiral. Right. And that was the end of my presentation. So if you have any questions, I will be glad to taking them.
Just raise your hand and I'll approach you with the microphone.
All right, I see the challenge of being the last one.
Yeah, that was probably to be expected.
Yeah.
So a big hand for Lovelesh.
Thank you. Thank you very much.